Surface Integral Formulas and Application Vector Calculus by Dr. Bezet. In this video, parametric surface integral formula, implicit surface integral formula, explicit surface integral formula. Dr. Bezet's video gives general idea about surface integrals. I would highly recommend you to watch videos in this playlist, Calculus 4, Vector Calculus. From Vector Analysis, Chapter 3, Vector Differentiation. This definition was very useful to understand surface integral. In this book, page 60, if you scroll down, you can find problem 3.25. Show that the equation R represents a surface. Show that partial derivative of R with respect to U, partial derivative of R with respect to V. The cross product represents a vector normal to the surface. Please read this part of the text, especially figure 36a, figure 36b very carefully. In figure 36b, when V is fixed, when U is fixed, when V is fixed, when U is fixed. At this point, if we take partial derivative of R with respect to U, this vector is tangent to this curve. When U is fixed, this vector partial derivative R with respect to V represent this tangent vector over this curve when U is fixed. Once again, partial derivative of R with respect to V when U is fixed. This vector is tangent to this curve. If we do cross product, this area is represented by this cross product. Once again, this area is represented by this cross product. Now, Calculus by James Stewart, 9th edition. In this book, chapter 16, the last chapter, section 16.6, parametric surface and their areas. Parametric surface. I would recommend you to read this part of text very carefully. If you scroll down, in page 1177, you can find surface area, the theory here. This explanation is very useful. In this episode, we'll be using this formula. If a smooth parametric surface S is given by the equation, this R is a position vector that parameterizes the surface S, and S is curved just once as UV ranges throughout the parameter domain D. Then the surface area of S is given by this formula, where RU is partial derivative with respect to U, RV is partial derivative with respect to V. We will use this formula in my current episode. If you scroll down, you can find example 10. We will solve this problem. Open up Visual Studio Code. CPP 17, 20, 23 parallel. Select empty space. Click this button. 207 surface. Hit enter. Click this button. Surface.cpp. Hit enter. Ctrl V. I will close this file. For my own reference in future, I will copy and paste these links. Please understand, I updated C++ library extensions and uploaded in this link. I will fold it up. Include CPG, CPG, SCD extensions. Include CPG, CPG, calculus. Namespace, CNA, CPG, numerical analysis, namespace, CPT, CPG, types. I don't recommend you using namespace declaration in the global scope. However, using namespace CPG numerical analysis commands using namespace CPG operators and constants. I would strongly discourage use of using namespace declarations in the global namespace scope. I will drag and drop James Stewart calculus. Now I will arrange side by side. Page 1178. We will be solving example 10. Void test surface area. Example 10. Copy this function name into main, paste it here. This example comes from Calculus 9th edition by James Stewart. Page 1178. 1178. Example 10. Find the surface area of a sphere of radius A. Or rho, I will let it 1.0 or A equals 1.0. The radial distance from the origin. Or R, CNA, create BCTR 3D. This is function. We need to parameterize vector R. Here, or phi, this symbol is phi, or theta. This symbol is theta. Phi is the polar angle in spherical coordinates system. Theta is the azimuthal angle in spherical coordinates system. The order should be maintained. Now, or R, we have to capture rho times SCD sine phi. R represent points in the xy plane in spherical coordinates system. Return R times SCD cosine theta, comma here, copy, paste. This is for fx. This is for fy. It should be sine. Or it can be said that return rho times sine phi times cosine theta. In this case, it can be said that sine theta. Now copy, paste, return rho times SED cosine phi. This represents FZ. So we created a vector R. This R represents a sphere in 3D coordinates system. Now here y is squiggle. It is not 2, it is 3. It takes 2 parameters. I will zoom it up like this. Now we have to compute partial derivative like this. How can we create partial derivative of r with respect to phi with respect to theta? That's very simple and easy. Although dr over dp, we can't use this because I defined it for some special purpose. Instead, r, p, r, t. We use this vector r, take derivative rp for dr over dp, rt for dr over dt. dt represent theta, dp represent phi. Now we take cross product, or dp cross rt, rp cross rt. This is cross product. Now, although we take magnitude over rp cross r theta, we can say magnitude, mag, rp cross rt magnitude. Please understand, we haven't provided parameters when we do derivative. Also, we haven't provided values for magnitude. At this point, mag represents magnitude of rp cross r theta. Now, we do integration. This part, although A is for area, CNA integral this magnitude, mag, SED, tuple, we pass range 0.02 times 5. This is for theta limits. D as a mussel angle. Copy, paste 0.05. This is for phi limits, the polar angle. Now here we have to specify in reverse order phi. So it should be d phi, then dt. Sorry, theta limits. So it should come dt here, then phi. SED, C out, area is A. This value should be 4, 5. CPG, and there. I will put carriage return here. Now we compute it. Open up any compiler. dir cd 207 surface clang ++ std c++ surface.cpp ltbb12 oc.exe, hit enter. CLSC. Wow, our numerical computation is identical with algebraic answer 4 pi. 4 pi. I will try with Intel compiler dir ICPX std C++ surface.cpp. I will use fno sickle or i.exe, hit enter. CLSI. So Intel compiler also works. If you want to display precision, you can do std cout precision, for example 10. We will use Intel compiler once again. CLSI. Perfect match. Before we move on, let's consider this problem again. At this point, we have to integrate magnitude of this cross product. To do integration in this part, make the cross product, the magnitude of this cross product should be function. If I haven't used functional programming, implementing such algorithm would be simply unbearable torture. Because I use functional programming, our algorithm is simple and elegant. I followed mathematical reasoning, not stupid computation. Now, copy this, paste. I will rename test surface integral. Example 1. From this document, scroll down. We will also use such formulas in future episode. Scroll down. In section 16.7, surface integral, please read this part of the text. Parametric surface. Scroll down. You can find example 1. Compute surface integral. Now we have x squared, where s is the unit sphere. As specified with this equation, everything is the same but for this integrand. Now copy this, paste it here. I will disable it. I would copy this text for your reference. Page 1184. 1184. Example 1. Compute surface integral. Now everything is the same. In this part, we actually don't need to do this. We can make it into a single operation, or make. We do cross product. Then we take magnitude. Of course, we can do this too. We can rebuild. Now I am using Clang compiler. CLSC. Of course, our result should be correct. Now we introduce x squared. X can be represented like this. Now here we can create auto integrand. We capture make auto phi auto theta. Don't miss semicolon. We can say auto x. This expression x equals sine phi times cosine theta. So I would copy this. Of course, you can do this too, but I will use namespace. Then return mag by theta, because this mag is a function times x times x, because we have to provide x squared or you can also do this too. In this case, we need parentheses. Now, we pass integrand here because it is function. Now, we rebuild using Intel compiler. Sorry, the exact answer is 4 pi over 3. 4 pi over 3. We will rebuild. I'm using Intel compiler. CLSI. Our numerical solution matches exactly with the algebraic solution. You cannot hate C++ more than I. I hate C++. I hate and love C++. You should pronounce it hate and love. I will create or extend from C++ to C++ or C triple plus.